them to methods, and even then you could pass ints, and floats. So it'll become obvious as I talk about ns number, which we'll do next week. Okay, so that's it for deck. Deck, very simple class as well. So let's move on to another class, which is playing card. Okay, the reason I'm showing you playing cards, I just want to show you what it looks like to make a subclass of another class that you've written. So playing card is a subclass of card, and this is the specific card, like King of Hearts, Three of Diamonds, that kind of card. Okay, now it has properties that are specific to a playing card, which is the suit and rank. Okay, the rank being like a 3, 4, a jack, king, right, and the suit being hearts, diamonds, clubs. And I'm going to represent the suit as a single character, the hearts character, the clubs character. You remember I typed the clubs character, I think in the card we might have shown that, I don't know, but you can type a single character. Unicode has a character for each of the 4 suits. So that's what my suit is going to be. And then the rank is going to be a number between 0 and 13. Is that king? Yeah. Representing the rank. So that's how I'm going to represent in my public API. And here I'm using, notice, NSU integer instead of unsigned int. So NSU integer and unsigned int are almost exactly the same thing. The only thing about NSU integer is it's type def. It might be a little different on different platforms. For example, the new iPhone 5s are 64-bit processors. So NSU integer is going to be a 64-bit int, unsigned int, on an iPhone 5. It might only be a 32-bit one back on an iPhone 4 and before. Okay? So that's a little bit different. So a minor nit. We're probably not representing integers. We're certainly here, we're only going 0 to 13. Probably doesn't matter. But we're not representing integers that are so gigantic that we're going to be using the 33rd bit. So notice that in playing card, we're overriding card method contents. Okay? We inherit contents from our superclass. And by default, contents just returns the value of whatever the contents property is. But here in the playing card, we're going to override contents to actually calculate our contents based on these other 2 properties. Okay, so we're overriding the getter of contents so that it always returns a string, the contents of this playing card, that is calculated from the suit and rank. See what we're doing here? So we're basically taking the storage of contents, underbar contents, from our superclass and ignoring it because we're overriding its getter. Okay, and so this is a perfectly valid reason why we do these properties as well, because we might have a better way to do things than the storage. Now, here's a way we could implement it. We could just return a string, okay, and a string with format is like printfing a string. Don't worry about that syntax too much. And I'm printfing a string with %d and %@. So %d means integer, %@ means an object, okay, a string representation of an object. And then I'm just using the rank and suit. So this would be one way to do my contents. It's not a very good way because, for example, the jack of hearts would say 11 hearts. Okay, well, no, it's not going to say J at least. We want to say J, not 11. So this is not a very good way. So instead, I'm going to make an array that has all the right things, like an A for a 1, and a J for 11, and a Q for 12, and a K for 13, right? So I'm just making this array here. I haven't, the middle there I had to cut out to make it fit, but right? And I even made 0 be question mark. So if your rank is 0, it's going to be like question mark, like unset. Your rank is basically not set. And then I return a string which is taking the rank out of that array and appending onto it the little suit string, the heart or the club or the diamond. Everyone understand this? I'm kind of giving you this so you can see how we're mixing in the array notation and message sending, and it all kind of seamlessly mixes in there. Okay? So now contents returns J hearts or 5 diamonds or whatever. Notice that our rank is really nice because if our rank is 0, which it starts out being when we say new playing card, all the instance variables are 0, so rank would be 0, we get this nice question mark. But our suit starts out as nil. And it'd be nice if the suit also returned question mark if it was unset, if it was nil. So here I'm just overriding the getter of suit to say if return, if my suit is nil, then return the question mark. Otherwise, if my suit's not nil, then return what the suit is. Okay? So I'm just kind of protecting my API to make sure I always return question mark when the rank or suit is not set. Yeah.
What's with all the @ signs?
Sorry, all the little @ signs, the red @ signs you mean? Yeah, I guess we didn't get to that in card, but we might have. But remember that all strings that we're going to work with in this class are string objects, not const char stars, right? They're string objects. And the compiler, if you put an @ sign in front of a string, it'll make a string object for you. Okay? So that's what those @ signs do. They make all those strings be string objects because we can't put a const char star in an NS array. NS array is for objects, so we have to put objects in there, like NS strings. Those are objects. Okay? Good question. Yeah?
When you overwrite the function contents for the in the previous thing, you showed that you could put gather equal is chosen.
Mm-hmm.
You could change the name. For here, do we also have to follow the same name? Or,
yes. Okay, that's a good question. If we had used that getter equals notation that we use for is chosen and is matched to change the name, then when we override, we'd have to use the new name. We'd have to is whatever. Now, this is not the case here, but I know what you're saying. And yes, you would have to use the new name. Great question. Any other questions about this? OK, so that helps the suit always return question mark if the suit is nil or not set. Let's also protect people setting the suit to something wrong. OK, let's only let people set the suit using this property, the public setter of the property. We'll only let people set the suit to be one of the 4 suits. So I just, on the fly, in the middle there, create an array of those 4 suits. And then I use this method contains object. What class do you think contains object is a method on? Anyone? Guessers? It's an NS array method, exactly. So contains object is an NS array method. I'm sending it to the array that I create right in place there, the array that has hearts, diamonds, spades, and clubs in it. And I'm just asking, do you contain this string? And that contains object is going to compare the contents of this string against all these using a method is equal. Actually, it's going to send is equal to all 4 of them with the suit as the argument. Not is equal to string, is equal. And in string, is equal is implemented by calling is equal to string if the argument's a string. Anyway, more detail than you need probably there. But this is obviously protecting us, so there's no way we can set our internal suit storage variable to anything except for those 4 suits. Yeah?
So in the 2 places where you have arrays, rank strings and also in the condition, it seems that you're allocating the array every time the method is called. Is it going to be efficient to like move it out, or does that not matter?
Great question. You guys are right on top of it. So every time I use the @ sign, open square bracket, the blue one to create an array, that's actually creating a new array every time. Okay? Because I told you that that @ sign square bracket and all this array stuff is really just calling methods. Well, that's calling a method like alloc init with array with objects or something like that, right? So it is creating it. So it would be nice to move it out, and we're going to do that. Although, again, be careful not to pre-optimize. It probably wouldn't make any difference. I'm only going to move it out to make my code cleaner. I'm not going to move it out for any performance reason. Yeah.
Oh, that was what I was going to ask.
Yeah.
Would LLVM just take care of that for you?
The question is, would LLVM just take care of that, optimize that out for you? And it probably wouldn't, because that's a message send. It's not sure what there might be side effects of it. But in any case, we're going to do it just to make our code look cleaner. And the performance would be negligible here. We're talking about UI. It's not even close. One thing to note, though, before we do that is, since we've implemented both the setter and the getter of suit, we are now required to do the @ sign synthesize. Okay? In other words, normally we don't have to do this @ sign synthesize. It gets done for us. But if we implement both the setter and the getter, now we do. And it's easy to do because it's always of this exact same form. But we do have to do it. OK. So let's do what we were saying. Let's take that little array of suits we have in there and put it in another method. Now, again, I'm not getting any performance by doing this. Okay, I'm just getting code cleanliness by doing this because I'm still, every time I call valid suit, it's going to create it again. Now, I could use a static variable. This is C. I could store this array, start it out being nil. If it's nil, set it to this array, and then it would only create it once. But be careful, again. Code cleanliness and understandably 10 times more important than performance like this. Unless you're going to call valid suits in an inner loop thousands of times, it's not really going to matter. But once I move that up into a different method, this kind of method that I moved it to is a little different. Notice that it has a plus. You see a plus there instead of a minus starting it? Plus NS array valid suits. OK, a plus method is a class method. OK, that means you send it to the class, not to an instance of an object. All right? So since you're not sending it to an instance, you can't use any instance variables or anything like that. You can only just kind of do generic stuff. So the only thing we really use plus methods for, class methods, is two things really. Creating things, like in the previous slide when we had string with format, that's a class method. That was creating a string for us. And then also utility methods like this, like that return constants and things that our class wants as utility methods. But here's an example one. And the way we call a class method, you've already seen me call a few of them, but here's calling it here, is we put open square bracket, the name of the class, the name of the method. And again, it could have arguments. It's just like any other method, but everyone understand this? Okay, and if you go back and look a couple slides and you see open square bracket NS string, string with format, same exact type of syntax. Okay, so that's what a class method looks like. Again, for creating things basically, and for utility methods. And we'll talk about the difference of when do we create something with a class method versus alloc init. We'll talk about that soon. I'm also going to make valid suits public. And that way people who are using my playing card know what the valid suits are. And all I need to do is put it in the header file. Boom, it's public now. Okay? So let's do a similar thing here with those rank strings. Okay? So I'm going to take those rank strings, that array of rank strings right up there, and I'm going to put that in a class method. Okay? And again, this is for readability, not for performance, because every time I call rank strings, it's still going to create that thing again. And then I call it instead up there. And I'm not going to make rank strings itself public, but I am going to make another class method called maxRank, which just looks at how many strings are in rank strings. And I'm going to return that as a public method. So there's 3 class methods for you to sink your teeth into. 2 of them public, 1 not. All right, and so they're all utility methods, right? We're not accessing any instance variables in any of those methods. Okay? That's the only reason I'm showing those, is just so you see what a class method looks like. We also could override the setter of rank, just to be complete here, to make sure it doesn't allow you to set a wrong rank, like set rank 15. There's no such card as 15, so let's make sure that the rank is less than the max rank, which is the utility method we just did. Okay? Does that all come together for you? Make sense? So this is kind of reference material. You have these slides that have all the annotations of all the things I'm saying, so feel free to go back and look at it and remind yourself about all these NS array, syntax, and all the class methods, all that stuff. Okay, the last thing we're going to look at is the init method business. Okay, so we're going to have another class here called playing card deck. Right, and a playing card deck is a subclass of deck. Right, and it has no public API. It's just going to override a method that it inherits indirectly from NSObject. Okay, NSObject through deck, which doesn't touch it, all the way to playing card deck, and that method is called init. Okay, so this is the same init, same kind of method that when we created that array, that mutable array, we said NS mutable array alloc init. So someone is going to call this playing card deck init method, namely you and your homework, are going to call this by doing playing card deck alloc and then on the outside init. Okay, and that's how you're going to create a playing card deck, and that is how we create most instances of objects. Not all. Sometimes we do things like the NS string, string with format, but most of the time, more than half the time, we do alloc and then on the outside init. Okay, listen carefully. Never call that alloc thing without wrapping an init around it. Okay, don't ever do that. That makes no sense to have an object allocated in the heap that's never been initialized. Always have that nested. And vice versa, never call that init except for when you wrap it around an alloc. And definitely never call that init more than once. Okay? And if you obey my rule of only calling it wrapped around an alloc, you can't call it more than once. Okay? Init is not something like you can re-init. Init happens once, right after alloc, and that's it. Okay? That is a hard and fast rule we never break. Okay? So you heard it here. Don't forget. All right, let's look at the wacky return type to this init method, okay? You might think that this init method should return a playing card deck star because it's kind of initializing and maybe it returns itself.